So a system of inequalities is just like a linear inequality, just like yesterday's notes, right? You have to be aware of the greater than, less than sign. So you have to be aware of shading. And you have to be aware of solid lines or dotted lines. And if you look, yesterday we had graph linear inequalities, and we asked what kind of line is it, which way do you shade, and remember the flip rule. Those still apply today, but today we're solving a system, meaning we have a different type of solution. Our solution is still that range where you shade, where you color, but a system means that there's two or more on the same graph. So, a system of inequalities is a set of two or more. Oh, it is really lagging. There we go. A set of two or more linear inequalities on the same graph. Two or more linear inequalities on the same graph. It's coming back. It's a set of two or more inequalities on the same graph. So if you think about yesterday, when you graphed, where was the solution? Like, how did you know what the answer to the problem was? How many answers were there to each problem? Infinite.
Infinite.
But were there wrong answers? Yeah. Remember, your answer was anything in that shaded area. If it's a dotted line, the answer is not on the line. If it's a solid line, the answer could be on the line. But there are wrong answers. Wrong answers would be anything in the unshaded area. So today, we're going to have two inequalities or more. We're sticking with two right now, on the same graph. So the solution is all ordered pairs in the double shaded area. All ordered pairs in the double shaded area. So let's try one. A system is shown by one of these funky bracket things. Oh, there it goes. It shows that they go together, that they belong together on the same graph. So our first one is y is greater than 1/2 x minus 2. And our second one can be x, or 8x minus 4y is less than or equal to 12. Is that good? Then I'm going to skip maybe 3 lines and put my graph so that I have room to solve, because that second equation needs to be solved for y, correct? Or that second inequality. And this is going to be where your color coding comes in, because one line is going to be one color and the other line is going to be the other color, to kind of help your brain see what's going on. Can I what? Can I? Oh, yes. I thought you said scrap bucket.
I would totally scrap buckets.
Where did my scrap buckets go?
My favorite
found
buckets.
So to graph this first inequality, right? Y is greater than 1/2 x minus 2.
Wait, where's the bracket on the other side?
It only needs to be on the front. It doesn't go inside two brackets. This just kind of shows you that these two belong together. So we're going to start at -2. So my y-intercept is -2. And from there, I'm going to go up 1 and over 2, because that's my slope. And I'm going to do that as many times as I possibly can. Going up 1 and over 2, up and to the right. And then when I run out of room, I'm going to do the opposite, which is down and to the left, -1, -2, because that's the same as +1, +2. Two negatives make a positive, right?
Sure.
Do I need to connect these dots? No, because there's not an equal sign. So there's my line. If you're a person that needs to make it dashed instead of like this, that's fine. And then which way do I shade?
I don't know, I don't get that part.
Y is greater, right? It's eating the y. So I start at my intercept. And where does y get bigger? Up, on top. Now, if you're using only one color, right, if you're just using your pencil, I would shade really lightly. Because we need overlapping. You have to see where they overlap. And if you shade really darkly, it's going to be hard to tell where they overlap. So then let's do the next one. And if I look at 8x minus 4y is less than or equal to 12, it's not graphable yet. I have to get y alone, so I'm going to subtract 8x from both sides. That leaves me with -4y is less than or equal to -8x plus 12, correct? I'm going to divide by -4. Leaving me y. I divided by a negative value, so I flip the sign. What's -8x divided by -4? 2x. And what's 12 divided by -4? -3. So there's my line that I'm going to graph, my inequality.
When do you flip the sign?
When your coefficient to y is negative. So I divided by a -4, so I have to flip the sign. If it was a +4, if I was dividing by 4, I wouldn't flip the sign. It's only when the negative coefficient of y.
So if it was like -y and then we have to divide each other by -1, we still flip the sign.
Correct. All right, so then I graph. This one starts at -3. And I go up 2 over 1. Up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. I go down to backward 1, down to backward 1, down to backward 1. Do I connect these dots?
Yes.
Why? because it has an equal sign with it. Then I find my y-intercept, and I'm going to shade up, or am I going to shade down? Y up. Because y is greater, correct? And y gets bigger going up, so I shade on that side of the line. Your answer to this problem is anything that's in the double shaded area. It's not right here because that's only purple. And it's not down here because that's only pink. It's wherever my purple and my pink overlapped. Now, here's the other part that you need to be aware of. Could the answer be down here on this dotted purple part? No, because it's dotted, correct? But could it be on this solid pink part? Yes. So sometimes it's a mixture of it can and cannot be on the line. It just depends on what kind of line it is. All right, let's try. Let's try this system. Y is greater than or equal to 4, and x is less than 3. No, we're going to do a third. Y is greater than or equal to -4, and x is less than 3. I know that they go on the same graph because they have that bracket in front of them. I don't need to solve for anything, right? So I don't need workspace. Are these diagonal lines? In order to be a diagonal line, you have to have an x and a y. These are not diagonal lines. What kind of lines are these? Horizontal or vertical? So we're going to do the same thing. I'm going to graph the first one and do my shading, and then I'm going to graph the second one and do my shading all on the same graph. So if I look, y is greater than or equal to -4. So on my y-axis, I find -4. It's already on the y-axis. I'm not going to draw a vertical line because there's already a line there, right? Look, there's an arrow, and there should be an arrow down here. It's not a vertical line. This means give me an ordered pair where the y value is -4. 2 -4. So over 2, -4. Give me another ordered pair where the y value is -4. 4. Over 4, -4. What kind of line is y -4? Horizontal. And this is solid, right? Because there's an equal sign. Am I shading up or down? Up. Y is greater. Where does y get greater? Up. So let's do the next one. X is less than 3. So on my x-axis, I find 3. And what that means is give me an ordered pair where your x value is 3. 3, 2. So over 3, up 2. What's another one? 3, 6. Over 3, up 6. 3, 10. What kind of line is this? Vertical. Is it solid or dotted? So I can just fill in some dots there. And is x greater or less than? Which way does x get less than? Which way does the x-axis go? Right and left. Which way does x get smaller? To the left. This one's a little bit different because it's not a y value, it's the x value. So then your answer, your solution, is any ordered pair in this double shaded area. Could it be on the green line? Yes. Could it be on the blue line? No, because it's dotted. All right, one more. Y is greater than 3/4 x plus 4. And y is less than 3/4 x minus 6. Y is greater than 3/4 x plus 4. And y is less than 3/4 x minus 6. If we go really quickly back to this second one that we did, y is greater than negative 4, and x is greater than or less than 3. If we go back to that second one we did, can someone tell me a possible solution that's in there? Give me an ordered pair that fits inside here.
Wait, which one?
Anna, give me one.
3.
Negative 4, 4. Okay, so here's how we check it. Our x value is negative 4, right? Is negative 4 less than 3? Yeah. And our y value is 4. Is positive 4 greater than or equal to negative 4? Any of these ordered pairs makes both equations true. If you substituted that ordered pair into both equations, it'd work for both of them. So let's try this one. Where does the first one start?
Positive 4.
Positive 4. And from there, what happens? Up 3 over 4. Up 3 over 4. Down 3, backward 4, down 3, backward 4. Do I connect them or leave them dotted? I'm going to dash them just so that you can see them a little bit more because they're kind of far apart. And does it go up or down? Y is greater. Then I'm going to graph my second one. Where does it start?
-6.
Negative 6. And from negative 6, what happens? Up 3 over 4. Up 3 over 4. Down 3 backward 4. Does this get connected? No. And do I shade up or down? Down. Because y is smaller.
What is this?
So the answer is,
Parallel
the answer is all the ordered pairs in the double shaded area. Is there a double shaded area? No. So it's no solution.
What? Aren't they also parallel lines?
They're parallel lines. So parallel lines are going to be a key to you. Sometimes parallel lines have solutions though. Yeah, like this one could have been, instead of it being less than, it could have been, I could have shaded above this. Right? And then it would have had double shaded areas. But parallel lines are going to be a clue to you that there might be something fishy going on.